to some calculus, and more specifically curve sketching, because obviously being able to look at a picture is very useful sometimes in our solutions. How can calculus help us? We learn about this thing called the first derivative and all its different notations. So we have y dash f dash x, d dx, where we actually list the function itself in there, whatever we're differentiating. Probably the most common of them all, dy dx, that type of thing. And what does it do? It's simply, when we're talking about the graph, is measuring the slope of that graph, or more particularly the slope of the tangent. Right? So when we say the slope of a graph, we're talking about the slope of the tangent at that particular point. What can it tell us, our first derivative? Well, if it has a positive tangent, the curve must be going up or increasing. And if it has a negative slope, then the curve must be coming back down. And consequently, if it doesn't have a value, if it's 0, then it must be stationary. Right? Let's use that idea. We've got the curve y equals 3x squared minus x cubed, so some sort of cubic. We're going to find our stationary points. We're going to determine what type of stationary point they are, and then we're going to give a very rough sketch. All we're going to use is the first derivative for this. There's my first derivative, 6x minus 3x squared. Locate the stationary points. Remember, don't get lazy in your setting out. Explain what you're doing. So that would be the first thing you would write down. Look, I'm trying to find stationary points. I know they occur when the derivative equals 0. This is why I'm solving this equation. So you don't just write that equation down. You say, well, why are you doing this? What's the purpose of it? The purpose is to find our stationary points. 6x minus 3x squared equals 0. Very simple one to solve. We get two possibilities. X equals 0 and x equals 2. We can sub that back into the function itself to get the y values. We've got our points. We want to know what type of stationary points they are. And we're only using the first derivative for this. The way we do it is with a table of values. But instead of having a y value, it's going to be, well, what's the derivative? Is it going up? Is it going down? Or is it stationary? That's really what we want to know. The point I'm investigating is 0, 0. I know at that point it's stationary, so that tangent would be horizontal. I need to pick a point either side to tell what it's doing. I can pick any point I like as long as I don't go past another stationary point, or if there's a discontinuity, in this case there's not, of course, we're talking about a polynomial, we don't go past the discontinuity. So I need to pick something on the negative side of 0 and something on the positive side. I'm going to use -1 on the left hand side, and that gives me a result of -9. I know the tangent's going down. And on the right hand side I'll use +1. That gives me a slope of 3. I know it's going up, and I can see from that nice little picture of tangents, oh okay, it must be a minimum. Therefore it's a minimum. Now, when you're drawing these table of values, don't be lazy. Actually write down what is the number that I'm substituting in, what is the answer. Let's do 2, 4 then. And it's the same idea. 2 is what I'm investigating, horizontal at that point. I need to pick a point on the negative side of 2 and on the positive side of 2, not going past my other stationary point. Well, it makes sense to use the one I've already worked out, so I'll use 1 here as well. But now on the positive side, what did I pick? I just went to 3, and that gave me there, and we can see, oh right, it's a maximum turning point. I say it's a very rough sketch. I'm just going to plot those 2 points in. Now really, when you think about it, because I know this is a polynomial, simply plotting those 2 points in, it's kind of obvious which one was going to be the minimum, which one was going to be the maximum. And there's a very, very rough sketch. I haven't bothered finding the x-intercept, although it would be quite easy to work out that particular one. But there it is. It's a sketch of the curve, just simply using the first derivative alone. Okay. So our first 2 exercises there, playing with that idea.